Hello everyone, in this part I am showing you the code in Arduino. In this code I am printing the temperature and the humidity value. I install the DST library. The DST pin is connected with 2 number pin and the DST type is 11. Here is the first serial print which name is DST final, and here is the two function which will give me the value of humidity and the temperature. Now I'm going to print the temperature value and the humidity value. I'm done with the code and already save it. Now I'm going to click sketch and click export compiled binary. I'm done with compiling. Now it is creating a hex file in my save location and I have to upload the hex file in Proteus.
Now I will discuss about the Proteus simulation part. First of all, I have implemented all of those components in Proteus. Here this is the Arduino Uno. Then this is the DHT11 sensor. Here power and ground is connected. Then here is a register. Then the virtual terminal. This one. And then the COM-PIM for the physical interface model. The Arduino Uno's TXT is connected with the virtual terminal's RXT, and the RXT of Arduino Uno is connected with the COM-PIM's RXT. Now, in the Arduino Uno, I will paste the programmable file which is already compiled in Arduino Uno with the hex code. Here it is. So now I will run it. Okay, now here we will see that the virtual terminal is showing about the temperature and the humidity.
Here, this is the graphical user interface of our data logger system. In this front panel, the temperature, humidity, and humidity meter and their waveform chart shows the fluctuation of temperature and humidity values. This table here also records the values after every 500 milliseconds. This block diagram is our G programming inside this big while loop. These two components will read humidity and temperature data from Arduino, and these two components will convert those data into string. This data will go to temperature meter and the waveform chart. Same goes for the humidity part. This component will get the time and date, and this component will convert them into string values. This is our build array function. We will put date, time, temperature, and humidity value into this array. These are our IDs, and this will also go here. The output will go to this array, which will update after every rotation. This shift register will control it. Here these two components are array and string constant. This is a local variable of this table, and the output from this array will go there. We will use Visa resource to select COM port, and this component is for error handling. To run the system properly, this constant need to be in false mode. So this is how the system will work.
Our LabVIEW and Proteus circuits are ready. Now we have to combine them. To combine LabVIEW and Proteus, we are using the configure virtual serial port driver. Here we have to choose two COM ports. We are choosing COM1 and COM2. Now we have to pair them up. After that, we have to go to Proteus and select COM1. And then we have to go to LabVIEW and we are selecting COM2 for LabVIEW, as we have already selected COM1 for Proteus. Now we have to run both Proteus and LabVIEW together to get the expected value.
Now we will run the system. First we will run it from LabVIEW. So we can see these values. We will run it from Proteus as well. Here the temperature is 50 and the humidity is 71. Also here we can see that the humidity is 71 and the temperature is 50. So if we increase the humidity and decrease the temperature to 44, we can see here that now the temperature is 44 and the humidity is 79. So we can see the real-time change here, and also we can see the fluctuation in this waveform chart. So this was our project. Thank you.